Hi, hello, this is Giri, teaching 10th Mathematics, the chapter Statistics. Here are the questions and solutions from exercise 14.1 and this is part 4 video. In this video, we will learn the solutions of question number 7 and question number 8 of exercise 14.1. Yes, dear children, this is question number 7. Find the mean concentration of SO2 in the air. I shall repeat. Find the mean concentration of SO2 in the air. SO2. SO2 stands for sulfur dioxide. Good. Now here you see concentration of SO2 and the frequency values are given as a table in the form of the table. If you observe, the concentration of SO2 is from 0.00 to 0.04. The frequency is 4. 0.04 to 0.08. The frequency is 9. 0.08 to 0.12. The frequency is 9. 0.12. You please correct this. 0.12 to 0.16. The frequency is 2. 0.16 to 0.20. The frequency is 4. 0.20 to 0.24. The frequency is 2. The first column, the first row is the concentration of SO2 and the second row is its corresponding frequencies. Now we have to find the arithmetic mean for this given data. Dear children, as we know that there are three measures of central tendencies, isn't it? What are they? The first is arithmetic mean, second is median, and the third is mode. Arithmetic mean, median, and mode are called measures of central tendencies. Out of the three, at present in exercise 14.1, we are practicing the questions on arithmetic mean. There are three methods to find arithmetic mean. The first is direct method, the second is deviation method, and the third is step deviation method. Now, let us solve this question using step deviation method. Now, in order to solve this question, first of all, we will consider the concentration of SO2s, that is the first row, as classes. Let these values be classes and these values are frequencies. You observe this table. Let us form a table now by taking 0.00 to 0.04 as the first class, 0.04 to 0.08 is the second class, 0.08 to 0.12 third class, 0.12 to 0.16 next class, 0.16 to 0.20 in the third last class, and 0.20 to 0.24. These are the classes, and corresponding to these classes the frequencies are 4, 9, 9, 2, 4 and 2. These are the frequencies. Now let us consider the mid values xi. Mid value or class mark. Mid value or class mark of any class can be obtained by finding the average of the lower and upper boundary of the particular class. Here, if you consider the first class, the lower boundary is 0.00 and the upper boundary is 0.04. If you add both, you will get 0.04. Now, what is the average? Means you divide 0.04 the sum with 2. 0.04 divided by 2 is 0.02. And the mid value, the next class, you add 0.04 to 0.08, you will get 0.12. 0.12 divided by 2 is 0.06. Similarly, 0.08 plus 0.12 is 0.20. 0.20 divided by 2 is 0.10. Isn't it? Similarly, 0.12 to 0.16, if we add these two, you will get 0.28. 0.28 divided by 2 is 0.14. For this class, how to find class mark? 0.16 plus 0.20 is 0.36. 0.36 divided by 2 is 0.18. 0.20 plus 0.24 is 0.44. 0.44 divided by 2 is 0.22. These are the class marks or mid values. After writing all the class marks, you can consider the mid value of a class which is having highest frequency as A, as assumed mean. A stands for assumed mean. Of course, you can consider any mid value as A, but in general usage, we may consider the middle class mid value as A, or you can consider the mid value which is having the highest frequency as A. I took 0.1 as A or 0.10 as A. If this is A, the next column is for deviation. Di is equal to xi minus A. For this class, xi is 0.10 and A is also 0.10. If we subtract xi minus A means 0.10 minus 0.10, you will get deviation 0. And for the next class, for this class, the mid value is 0.14, xi is 0.14 and A is 0.10. Therefore, if you subtract 0.10 from 0.14, you will get 0.04. Similarly to this class, 0.18 minus 0.10 is 0.08. To this class, 0.22 minus 0.10 is 0.12. Isn't it? Now come to these classes. 0.16 minus 0.10 is minus 0.04. To this class, deviation is 0.02 minus 0.10 is minus 0.08. These are the deviations. The next column is for UI, step deviation. UI, the formula to find UI is di divided by h. Here h means height of the class. How to find h? H is nothing but the difference between any two successive lower boundaries or any two successive upper boundaries. The difference is always same, which is equal to 0.04. Therefore h is equal to 0.04. Now you divide all these di values one by one with 0.04. Understand? Minus 0.08 by 0.04 is minus 2. Minus 0.04 divided by 0.04 is minus 1. 0 divided by 0.04 is 0. 0.04 divided by 0.04 is 1. 0.08 divided by 0.04 is 2. 0.12 divided by 0.04 is 3. These are UI values. We have UI values and you have frequencies already. Frequencies will be denoted with Fi and these are UI values, and let us multiply Fi with its corresponding UI value and you may write this product here. This column is for Fi UI. Fi into UI. 4 into minus 2. Minus 2 4 is 8. 9 into minus 1. Minus 9 1 is 9. 9 into 0 is 0. 2 into 1 is 2. 4 into 2. 4 2 is 8. 2 into 3. 2 3s are 6. Now we wrote all positive values in a row and negative values in a separate row, so that it will be easy to find its sum. Now let us find sigma Fi UI. Sigma Fi UI means sum of all these products of Fi UIs. Let us add positive values first of all. 2 plus 8 is 10. 8 plus 6 is 16. Minus 8 plus 9 is 17. Plus 16 minus 17 is minus 1. Sigma Fi UI is minus 1. And now sigma Fi. Sigma Fi means sum of all the frequencies. Let us add all these frequencies. 4 plus 9, 13. 13 plus 9, 22. 22 plus 2, 24. 24 plus 4, 28. 28 plus 2 is 30. Sigma Fi is 30. Sigma Fi UI is minus 1. And A is 0.1 or 0.10 is A value. Now, as you are finding the arithmetic mean in step deviation method, let us write the formula for arithmetic mean for step deviation method. The formula to find arithmetic mean in step deviation method is AM is equal to A plus sigma Fi UI divided by sigma Fi into H. This is the formula. Here A value is 0.1 and Fi Ui value is -1 and sigma Fi is 30 and H means the difference between any two successive lower boundaries or any two successive upper boundaries or the difference between any two successive mid values. The difference is 0.04 is H value. AM formula, AM is equal to A plus sigma Fi Ui divided by sigma Fi into H. This is the formula in which let us substitute A is equal to 0.1 plus sigma Fi Ui minus 1 plus sigma Fi 30 into H is 0.04. And now let us simplify this value. This is 0.1 plus into minus is minus 1 into 0.04 is 0.04 divided by 30. Okay, 0.04 divided by 30. Here how many places are there after decimal? After decimal there are 2 places. Therefore, if you remove this decimal and if you write 4, then you have to keep 2 more zeros beside 30 so that it becomes 3000. This is 0.1 minus 4 divided by 3000. Now divide 4 with 3. You will get 1.3. 1.3 divided by 1000 now. 1.3 divided by 1000 means 0.0013. Okay. Therefore, the simplified value of 4 divided by 3000 is 0.0013. Now you subtract 0.0013 from 0.1. If you subtract 0.0013 from 0.1, you will get 0.0987. Therefore, arithmetic mean of the given data is 0.0987. If you correct it to 3 places, the 4th place is 7. Since it is more than 5, you may add 1 to its preceding digit. Therefore, this is 0.099 is the arithmetic mean of the given data. Very good. Dear children, now let us solve question number 8. Here is question number 8. Find the mean literacy rate of 35 cities. Shall repeat. Find the mean literacy rate of 35 cities. Here is the first row stands for literacy rate and second row gives the values of number of cities. The first is literacy rate. Now the number of cities in the literacy rate in between 45% to 55% is 3 and the number of cities in the range of 55% to 65% is 10 and the number of cities in between 65% to 75% is 11 and the number of cities in the literacy rate between 75% to 85% is 8 and the number of cities in the literacy rate of 85% to 95% is 3. Okay. Now this is the first row stands for the literacy rate and second row stands for the number of cities. Now in order to find the arithmetic mean, let us consider the literacy rate as classes and the number of cities as frequencies. Now look at the table. Let us form a table now with classes 45 to 55, 55 to 65, 65 to 75, 75 to 85 and 85 to 95. These are the classes. And corresponding to these classes, what are the frequencies? The frequencies are 3, 10, 11, 8, 3. These are the frequencies. After writing frequencies, let us find sigma Fi, sum of all the frequencies. 3 plus 10, 13, 13 plus 11, 24, 24 plus 8, 32, 32 plus 3 is 35. Sigma Fi, sum of the frequencies is 35. The next column is for mid value or class mark. Mid value the first class means add these two. 45 plus 55 is 100. 100 divided by 2 is 50. Therefore, the mid value of the first class 45 to 55 is 50. Now, what is the class mark of 55 to 65? Again, add these two. 55 plus 65 is 120 divided by 2 is 60. 65 plus 75 is 140 divided by 2 is 70. 75 plus 85 is 160, divided by 2 is 80. 85 plus 95 is 180, 180 divided by 2 is 90. These are the mid values. After writing the mid values, you can consider the class which is having the highest frequency. Corresponding to this highest frequency, you can take the mid value as a assumed mean. If this is assumed mean, okay, if this is the assumed mean, then the next column is for deviation. Deviation di is equal to xi minus a. To this class 65 to 75, xi is 70 and a is also 70. Then what is 70 minus 70? You may get 0. And to this class xi is 80 and a is 70. Then what is 80 minus 70? This is 10. And to this class xi is 90 and a is 70. What is 90 minus 70? 90 minus 70 is 20. You please correct this. This is not 100. It is 20 only. This is 20. Okay. Now here to this class xi is 60 and a is 70. Then what is 60 minus 70? Minus 10. To this class xi is 50 and a is 70. Then what is 50 minus 70? Minus 20. These are deviations. The next column is for ui. The formula to find ui is di divided by h. Di means deviation, divided by h means the height of the class. What is the height of the class? The difference between any two successive lower boundaries or the difference between any two successive upper boundaries may give h value. Here the difference is, if you observe, 55 minus 45 is 10, or 85 minus 75 is 10, or 85 minus 75 is 10, or 65 minus 55 is also 10. Therefore h is 10. So minus 20 by 10 is minus 2. Minus 10 divided by 10, minus 1. 0 divided by 10, 0. 10 divided by 10, 1. This is 20, we corrected. 20 divided by 10 is 2. These are ui values and these are fi values. Now let us multiply these two values. 3 into minus 2 is minus 6. 10 into minus 1 is minus 10. 11 into 0 is 0. 8 into 1 is 8. 3 into 2, 3 2s are 6. If you observe this, I wrote all positive values in a row and negative values in a separate row in order to add them. Sigma fi ui is equal to 8 plus 6, 14. Minus 6 minus 10, minus 16. What is 14 plus 14 minus 16? This is minus 2. Sigma fi ui is minus 2 and sigma fi is 35 and a is equal to 70. Clear? Now we have all these values and we are going to find the arithmetic mean using step deviation method. Therefore, let us write the formula to find arithmetic mean using step deviation method. Using step deviation method, arithmetic mean formula is a plus sigma fi ui divided by sigma fi into h. This is the formula to find arithmetic mean using step deviation method. From this table we know that a is equal to 70, sigma fi ui is equal to minus 2, sigma fi is equal to 35 and h, height of the class, is 10. We wrote all these values and am is equal to a plus sigma fi ui divided by sigma fi into h and substitute these values one by one. A value 70 plus sigma fi ui is minus 2 divided by sigma fi is 35 into h is 10. This is 70 plus, if you observe, this is 35 and this is 10. 5 can divide 35 and also 5 can divide 10, isn't it? 5 in 10 2 times and 5 in 35 7 times. Here 5 divided 10 2 times. This 2 into this minus 2 is minus 2 2's 4 divided by 5 in 35 7 times. This is 70 plus into minus minus 4 divided by 7. 4 divided by 7 is 0.57. What is 70 minus 0.57? 69.43. Therefore, the arithmetic mean of the given data is equal to 69.43. By this, we concluded the exercise 14.1. In this exercise 14.1, we solved most of the problems using step deviation method only. Of course, you know that there are three different types. The first is direct method, deviation method, and step deviation method. We solved one or two problems using direct method and one or two problems in deviation method, and all other remaining problems in step deviation method only. As the step deviation method is more useful, we gave more importance to step deviation method, and you can understand all these three methods one by one, so that you can solve all these problems in any of the method that you want. All the video links of Introduction to Statistics and the questions and solutions from exercise 14.1 are provided in the description. You can click the video link and you can observe the videos whenever necessary. Thank you one and all.